Okay, let's continue with the next, the final video lecture of machine learning. Okay, a part of linear classifier, we also have lazy learners. So what is lazy learners? Similar like human. Okay, for example, in class, we have some lazy learners, then lazy student who, they don't participate in class. When we give example or exercise, they don't really want to do. And up to the extent, the worst is even if they were called in front to share their information or opinion, they don't want to. Okay, so that's lazy learner. So why do we have lazy learners in machine learning as well? Okay, so of course, because we want to mimic humans, so sometimes this also good. Okay, so how do we know whether it's a lazy learners? They don't make any decision after the training data until the new case is given to them. Okay, so generalization beyond the training data is delayed until a new test data or new instances is provided to the system. Okay, for example is the k nearest neighbor. Okay, you give all the data with all the labels, okay, until when you give the new instances, okay, and then you say, okay, I want to know the k nearest neighbor. So for each data here, they will find only the nearest 3 neighbor to them. If you give 5, so they will take the 5 nearest neighbor as their cluster or as their groups. Okay. Another type of learning, okay, is decision tree. It's like a flow chart tree structure, okay, whereby you have a decision here. So it's like a rules, okay. If x2 is less than 3, you go to the left. If not, you go to the right. Okay, and then you have another threshold or condition to check here. If x1 is less than 4, then it's a blue. If not, it's a red, and etc. Okay, so this, okay, can also be represented in graphs like that. Okay, so that is the x1 and x2 value there. Right, and then we also have a neural network model. Okay, basically the interconnected between input nodes and hidden nodes and the output nodes. Okay, so the input nodes basically all the parameters. If in your work group project is the features of the images, okay, you have hydraulic features and then reduce the features using a PCA. So that features would be the input. So if it is 50 features, you're going to have 50 nodes in the input layer. Okay, and then if you use a classifier, you should be able to change or specify how many nodes in the hidden layer. The more nodes, the more complex you're going to have the interrelation here. Okay, and then this is also a mathematical model. They will do the calculation, okay, to get finally 1. So this will be the output. Okay, neural network model, the prediction output is a series of numbers. So how many movement from input layers to hidden and then go to the second features, go back and forth to the output layer and etc. and sum up until it gets the best predicted output. Alright, then we also have ensemble classifier. Okay, if you read papers, now this is becoming a trend, ensemble learning. Okay, what is actually ensemble learning? We combine a few weak classifiers, okay, hoping that weak classifiers, when they combine, because even though it's weak, but they have their strength in certain area. So we hope to combine the strength of all these weak classifier. So this is an example, graphical example here. We have data like this. So the weak classifier might produce this model, okay, which trying to segregate between the blue dots here and the 2 red dots on top. Okay, and then you try another classifier, weak classifier, maybe they will produce another line like this. okay, because it's not good, so they don't give a good output. Alright, and then another classifier might make line like this. So you combine them, okay, hopefully we can have this line, okay, giving a better and perfect output using an ensemble classifier. Okay, so this is an example to show you in face recognition problem, training example of a person. I hope you know that this is the same person, okay, but different face, different angle, and different magnification, okay. So we feed this information, okay, into the machine learning. They will try to find the characteristic between the same image, because we say that this is the same people, okay, we label them. These 4 images belong to, for example, Mr. Tim. So they will find the characteristic between these 4 images, and then we give a test image, okay, should be able to identify that this image is the same class with the other 4 images. Okay. Next, we have supervised learning in regression. Okay, regression, the label is just a number. Okay, so label is a real value. So we have the application, basically all the mathematical formula, the application in navigating a car to decide the angle of a steering wheel in navigating a car. Of course, this car is without driver, okay, and also kinematic of a robot arms in a factory. Okay, and then we also have a ranking for supervised learning, where the label is actually a rank. Okay, the application is in your Google search. Okay, they will give you based on frequency of people who cite or look at that particular website. Okay, so they will rank them according to relevance. If you can test after this, look at Google when you search for something or images, right? You can see that, right? You want to find web or images, map, shopping, and etc. And then you can also filter, or you can also change the ranking based on the relevance or based on certain characteristic. Okay. So as I said, it's in Google, Netflix in my list, iTunes, flight search, and etc. Okay. So we finished the supervised learning. Now unsupervised learning. Unsupervised learning, basically, we give the trainings, okay, without telling the labels. Okay, that's the distinct difference between supervised learning and unsupervised learning. Unsupervised, you don't give the label. Okay, so learn what normally happens. Okay, and there's no output for specific test data. So usually they will just use a clustering to group similar instances. Okay, let's look at the example here. We have unsupervised learning. Okay, we just give these images, okay, into machine learning, okay, and we'll see what the machine learning will find out about this. Okay, whether the distinct features is a color or distinct features is a shape. Okay, and I will give a new images. We'll see whether they will group that into an apple or group them only with the red apple, meaning that they based on the color. Okay. The third one is in unsupervised learning is to learn association. Okay, we want to know what is the relationship between certain parameter. Okay, in this example, okay, basket analysis, okay, if we want to open up a shop, okay, we want to know in that area what usually customer buys. Okay, so based on the experience, we have that customer first will buy bread and milk. Second customer, bread, diapers, soft drinks, eggs. Okay, third, milk, diapers, soft drinks, cokes, and etc. Okay, you can read there. So we want to know what are the association between this. From the frequency, you know that almost everybody buy bread. Okay, but apart of bread, usually when people come buy bread, what else do they buy? Okay, so you can associate, okay, with milk. Okay, as a human, you can see this straight away because there's only 5 data. Okay, what about if you have 1,000 customers? Okay, that's why if you want to know why, you can see now almost everywhere you have 99 speed mud, right? And how this 99 speed mud chaining has boomed up. Okay, and what is the difference between the 7-Eleven? Okay, they do a basket analysis. Okay, and they targeted which area, which customer they want. Okay, right. For 7-Eleven, for example, they targeted those customer who always come to their shop after 9 or 10 p.m. Okay, so they offer different kind of products. Okay, so this is unsupervised learning for clustering. Okay, they cluster group based on the distance here. Okay, so there are many types of distance measurement. You have Euclidean distance, you have Manhattan distance, and many more. Okay, unsupervised learning also used in anomaly detection. So basically, we have 3 clusters here, or 3 groups who are plotted in a similar area, but we have 2 which is far from any of the rest. Okay, so this is as an anomaly. The application for unsupervised, okay, to learn cluster or groups, okay, to segment type of customer, to compress image, as well as to learn motifs or pattern. Okay, the last type of machine learning is reinforced learning. Okay, this is interesting, okay, because this is another type of how we train a human. Okay, for example, if you have a small kids or maybe a younger brother, about 2-3 years old, okay, the way we teach them is either you use a reward or a punishment. So exactly like this, reinforcement learning. I don't know why the screen keep moving. Alright, so reinforcement learning, for example, if a toddler, okay, they want to play climbing up and down the stairs, so we say no. Okay, of course they will try again to do the same thing. So if they do good thing, they obey you will give them a reward. Okay, you say, oh, good boy, you give them a kiss, you hug them. And if they didn't obey, okay, you scold them, for example. So that is a reward and punishment. So that is reinforcement learning. Okay, so not supervised output but a delay reward. Okay, so we give a reward by using a weightage. In machine learning, we can give a positive or negative value as a weightage for it's like a bait, okay, for the machine to take that path compared to another path. Okay, so the application mostly in game playing, okay, or robot in maze, or as well as in agents. Okay. Right, that's all for machine learning. Another example in games, okay, you have Candy Crush and also Pokemon here. Okay, please do the exercise by giving me what is the penalty and rewards in these 2 games. Okay, good luck and hope you have fun. Thank you.